Today we are going to look at that is chapter 9.3, where we will consider various things such as double angle formulas and such. First, to look at double angle formulas, please look at page 848, okay, where we are reminded of the sum of angle formula, which is sine alpha plus beta, which is sine alpha cosine beta plus cosine alpha sine beta. Now, what if I substitute alpha and beta to be the same thing? They both, and call them both theta. In that case, then following the formula, we'll have sine theta cosine theta plus cosine theta sine theta. But these are the same stuff, right? I mean, they are no different at all. So then, which means they're just two sine theta cosine theta. So just from this, we have just proved the double angle formula for sine. That is sine 2 theta equals to 2 sine theta cosine theta. That's the first formula. The next formula we're going to look at is the cosine double angle formula. How does cosine work? Well, we're going to do the cosine exactly the same way. That is cosine of alpha. Where's the cosine? It doesn't, I guess, it doesn't really say that, but we'll just remember it, okay? So cosine of alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta. Substituting both things as theta, then we have cosine theta, and sine theta minus sine theta and sine theta. What does that equal to? That would be simply cosine squared theta minus sine squared theta. So that is the formula for cosine 2 theta. Right there, okay? They are both proven with one line. However, the cosine double angle formula has a slight variation. That is, being that they're both squares, right? The cosine 2 theta equals to cosine squared minus sine squared. We can substitute cosine squared by the Pythagoras theorem. That is, cosine squared is 1 minus sine squared. So we can plug that in here. Okay, plug 1 minus sine squared instead of cosine squared. And so then we end up with 1 minus sine squared minus sine squared again. So 1 minus 2 sine squared. That is the formula for an alternative formula for cosine 2 theta. And then, well, that's just because cosine 2 theta is made with two of them. With two squares, so then we can substitute stuff in there and make things look a little different. And so similarly, so just now we substituted cosine squared. We can easily do the substitute sine squared instead, because sine squared theta is 1 minus cosine squared theta. So plugging that in, okay, and looking at this carefully, you notice that just equal to cosine squared minus becomes a plus. Another cosine squared becomes 2 cosine squared minus 1. And that is cosine 2 theta. So cosine 2 theta has 3 different formulas. Okay, the very first one was cosine squared minus sine squared, or 1 minus 2 sine squared, obtained easily from the Pythagoras theorem, or 2 cosine squared theta minus 1, again obtained easily by the Pythagoras theorem. So that's that. Now next, what is the last thing we're going to do is the tangent formula. How does tangent work? Well, obtaining the original tangent, sum of tangent, then tangent alpha plus beta is tangent alpha plus tangent beta divided by 1 minus tangent alpha tangent beta. That's multiplication there. So then if we plug in theta, both alpha and beta substituted as theta. Okay, so that way we have 2 thetas. Then on this side, it will become tangent theta plus tangent theta, which give us 2. Okay, and then 1 minus tangent theta times tangent theta, being the alpha and beta in the formula both turned into theta, that becomes 1 minus tangent squared theta. And that is the formula for tangent 2 theta. And that is also our formula that is summarized on the next page. So please turn to the next page and take a quick look at the formulas that we just proved. Very easily, I might add, by using the sum of angle formulas that we learned in the previous section. So now that we know what are these things? Oh yeah, double angle formulas. Then we can do some stuff with it, I guess. Let's then look at example 1. Okay, we have so example 1. Let me write it down. Okay, now I wrote down example 1 on page 849 where tangent theta is minus 3 over 4, and it states right here that the angle theta is in quadrant 2. The quadrants are counted like this: 1, 2, 3, 4. So in quadrant 2 is right here, and that makes sense because the tangent theta is negative. To be negative, then in this quadrant y is positive, right, and x is negative. So the tangent value is calculated as y divided by x, so it will be negative in the second quadrant. So here's our theta, and is angle, the reference angle, and measures at opposite is 3, okay, and the adjacent is 4. Tangent is opposite divided by adjacent. Okay, says right over there. So this side then, this is the 3, 4, 5 triangle, because 3 squared plus 4 squared is equal to 5. All right, so that is that. Then now that we know that, we have to calculate sine of 2 theta, cosine of 2 theta, and tangent of 2 theta with the formulas that we just learned, which is right on top of this page, in fact. So let's look at the top of the page. And so to find the sine 2 theta, etc., isn't that what we're supposed to look for? Yes, we are. Now, looking at the formulas that we just learned, you notice that to calculate them, we need to find the values of sine theta, cosine theta, and tangent theta. Okay, so let's do that. Tangent theta is here. So what is sine theta? Let's figure that out. The sine theta equals to here's theta. We only consider this is the reference angle. All the trigonometric values are calculated this way. Okay, so sine theta is, what was it? Opposite over hypotenuse. So this is opposite over hypotenuse. Okay, so which is 3 over, this is hypotenuse, sorry, it's 5. Okay, and that is adjacent. So 3 over 5 is sine theta, and the 3 is positive, and because it's on the top, on the positive y value. And next, cosine theta is equal to adjacent over hypotenuse, so it's 4 over 5. However, you notice that because the adjacent side is on the negative x-axis, so it is minus. Anything on the negative axis has to be minus. The hypotenuse doesn't have a sign, okay? It's just it's always positive, or you just ignore it. You don't have to worry about the sign for that. So this is sine theta, cosine theta, and tangent theta. And with that, we can calculate what do we need? First thing we want to figure out is sine 2 theta. So sine 2 theta, this is part A, sine of 2 theta equals to, according to the formula right here on top of the page, 2 sine theta cosine theta, which is equal to 2 times 3 5ths times minus 4 5ths, and that equals to, let's see what the book says on the next page. Yep, and then we just have to do the residual math, then that will come out. I will write it over, I'll write it over here. Okay, so that is just 25 over times negative, that's 12 times 2 is 24, and that is what the book says as well. All right, so that's sine of 2 theta, and cosine of theta is cosine of 2 theta. You follow the cosine 2 theta formula, and there's 3 of them, and you might wonder which one do I follow. Pick one, doesn't matter, they're all kind of the same. That is, they will all provide the right answer, the same answer. They better. Okay, and then tangent theta, you just plug in the tangent value right here that was already given into this tangent formula to calculate the answer. So please do that yourself, and the book gives explanations. Well, yeah, so please do that, and we will move on to the next example, which is example 2. Example 2 says use the double angle formula for cosine to write cosine 6x in terms of cosine 3x. Cosine 6x is, okay, so let me write that down. All right, now here's example 2 on page 850. It says that we have to write cosine 6x in terms of cosine 3x. That is, we'll let theta equal to 3x, okay? So let theta equals to, that is horrible looking. Let me fix that. Okay, let's see. We have let theta equals to 3x. So this is cosine of 2 theta, okay? Cosine of 2 theta, and we have to express this in terms of, with just theta only. Now, so let's look at the formula that we had. Let me pry this thing out a little bit. Okay, now cosine, where is it? Right here. Now, let's look at that. We need the cosine 2 theta, and we need to change it into such that it has only cosine theta in it, okay? Because theta is 3x. Which formula has just theta? Cosine theta, I mean. This one right here, so we'll change it into this one. So cosine of 2 theta, copying from the book, is equal to 2 cosine squared theta minus 1. And this is from this is just from the previous page. And we have, okay, so that is that, and that is the answer. Then theta is 3x, so we write that down. In other words, cosine of 6. 2 theta is 3x, so 2 theta is 6x. We have 6x, cosine of 6x, then equal to 2 times cosine of 3x squared, 3x minus 1. Okay, this 3x is in parentheses, and to be correct. Let's see, that should be, that is example 2. Yep, and next let's look at something else. And turn to the next page, 851. Let's look at example 3, where we're supposed to verify that 1 plus sine 2 theta equals to sine theta plus cosine theta squared. Okay, so let's do that. Let me write that down. All right, I wrote it right here. Problem 3, which is 1 plus sine 2 theta. And what do they want? They want it to crank this thing into with just theta. Okay, there's no 2 theta left, but we can have cosine theta thrown in if then and stuff. So to make this equation come out, what we're going to do is first we will notice the 1 is equal to sine squared plus cosine squared by the Pythagoras theorem. So we'll write that down. Sine squared theta plus cosine squared theta. And this is just 1. Okay, that's the 1 part. And then plus sine 2 theta, we're going to pull out that formula that we just learned, the double angle formula. Sine 2 theta says right here, okay, on the previous page, sine 2 theta is 2 sine theta cosine theta. So I will write that down. 2 is 2 sine theta cosine theta. All right, so then this, what is this thing? This is a, we'll consider sine theta as a. So this is a squared, okay, plus, and cosine theta, we'll call it b. So this is b squared plus, and 2 times a times b. There's a formula to factor this thing out in algebra. This is simply equal to a plus b squared. So this is equal to a plus b squared. So that's what we're going to write down. That the original thing we have here is equal to sine theta plus cosine theta squared. And that's, I think that is the answer we're looking for. Let me see. Proving identities is about, you just do something that looks like it might get you somewhere and hope that it does. That is how you prove trigonometric identities, okay? You just beat it around and you flip it and poke at it and go this way and that way, and maybe it'll come out. And it should come out if it's true. So that is, now your book started on, yep, that is correct. That's what we're trying to prove. Now your book started on the other side. It started as sine theta plus cosine theta. That's fine too. Nothing wrong with that. So please go over that yourself, okay? And then we're going to move on to the next step. Example 4. Next, let's look at example number 4 on page 851. We are trying to prove that tangent 2 theta is equal to 2 over cotangent theta minus tangent theta. Okay, so the book did it one way. So I will start it on this side. Nothing wrong with that. But I will start on this side just to give you yet another perspective. And the two, you basically end up doing the same thing. Okay, it's like walking from A to B rather than walking from B to A. You see more or less the same scenery. It just might be in reverse order. So I'm going to start on this side. Okay, starting with this then equal to, what is this equal to? This then equal to, looking at that, okay, that equals to 2 over cotangent is defined as 1 over tangent, okay? Cotangent is 1 over tangent, so I write it down right here. So it's 1 over tangent theta. And then this side is minus tangent theta. I will write it as tangent squared theta divided by theta, tangent theta. That way I have a common denominator here. Okay, and then which means I can effectively, this is make it into one fraction. So 2 is being divided by 1 minus tangent theta squared over tangent theta. So this is one single fraction, and to divide by a fraction is to invert and multiply. So I will do that. So this is the same as 2 times, okay, to invert this function. So the tangent theta, the denominator is just tangent theta goes on top, and the numerator is 1 minus tangent squared, and that's on the bottom. Tangent squared theta is on the bottom, and then I will write this equal to, okay, and 2 times all that. And actually, I will move the 2 in here. So let's move the 2 right here, and then, so that's that. Now, what is that? So this thing is equal, I'm working on this thing equal to this, but what is this? This is, let's look at our pack of formulas. You notice that happens to be exactly the formula for tangent 2 theta. See, compare that to the previous page. Tangent 2 theta equals to 2 tangent theta over 1 minus tangent squared. Just like it says. See, it says the same thing right here. So this is, so we're done. So this, what is that? Oh, yeah, that is equal to tangent 2 theta. And then we are done with the proof. And so the book proof started, I think, from this point and go this way and get back there. So like I said, they're walking from B to A, and I'm going, A to B, and I'm going from B to A. Either way is you're doing basically the same thing. To prove it. So please look at the book's method yourself, okay? Make sure you understand it and know how to do it. And work through all the examples that I talk about yourself as well. Now, the way you do that is by looking at this the way I do it. That is, you look at the problem, then you put down the book and try to do it yourself, okay? And then check with the book to see if you've done it right. So that's that. And next, let's consider what's this? Reduction formulas. Okay, we're going to have a bunch of reduction formulas. What are they? And let's look at one of them. This is we are now on the next page, page 852. So on page 852, please, let's look at some reduction formulas. The first one, and what are we reducing? What the reduction formula is that we are turning stuff that has squares in it into stuff that doesn't have squares. And for example, on this page, look at the, I don't know, this is about the middle of the page, page 852 here, okay? That says on the board, see, right here. But anyway, what we're trying to do is we'll reduce sine squared, which is kind of hard to deal with, into something that doesn't have squares in it, okay? It got turned into a cosine 2 theta, etc. So that will, the purpose of that is in calculus, that will make certain things easier. So that's why we're doing this. So these are called reduction formulas. And how do we come up with this stuff? So let's look at it a little closer, okay? And starting from the first line, cosine 2 theta is 1 minus 2 sine squared theta. We got that from one of the cosine 2 theta formulas. Oops. Right here, okay? That's, see the middle one? 1 minus 2 sine squared theta. That's what we just had in this section. So knowing that, then we're going to manipulate that. So move the minus 2 sine squared over here, okay, and then that gives and then put the cosine 2 theta on the other side, it becomes a minus. So we got here, and then divide by 2. That's it. We got the formula for sine squared. And we can reduce sine squared into a cosine calculation that doesn't involve squaring it. Okay, it's just cosine of some angle. That's all you have to do. Now the next step is that's for sine squared. For cosine squared, we are gonna do something similar. And first, we'll start with another cosine 2 theta. Remember, cosine 2 theta has more than one formula. There's the one over there, but there's also this one right here. Cosine 2 theta is 2 cosine squared theta minus 1. And that is on the previous page. See, right here. And one of them says, see, cosine 2 theta equals to 2 cosine squared theta minus 1. All right, so knowing that, so we are starting with that thing, and then we're gonna isolate cosine squared because that's what we're shooting for. Okay, so we'll put the minus 1 on the other side, it becomes plus 1. So we got here, and then we just divide by 2, and suddenly we have the reduction formula for cosine squared, in the sense that we can express cosine squared in something that doesn't have a square in it, and that sometimes makes life easier for the calculus students. Okay, so that becomes our reduction formula for cosine squared. So far we have found the reduction formula for sine squared right over here, and then cosine squared right here, and then so the next one we need is the tangent squared. So to calculate the tangent squared, then we at the bottom, then we need to pull a different trick than what we've been doing. And the different trick actually turns out to be the old trick. That is, we know that the tangent is defined as opposite divided by adjacent. That is, tangent is given as sine theta over cosine theta. So knowing that, then we know that and we just did what the reduction formulas for sine squared is. See, sine squared is that thing, and cosine squared is this thing. You notice they're only different from a sine. There's a minus and there's a plus. That's the only difference between the two formulas. But never mind that. We are going to just use what we just learned, okay, plug it in. So tangent squared is sine squared over cosine squared. We just learned that sine squared is 1 minus cosine 2 theta over 2. Cosine squared is 1 plus cosine squared cosine 2 theta over 2. And we're just going to put these two things together. This is a top fraction. This is a bottom fraction. The top fraction is dividing by the bottom fraction. To divide is to invert and multiply. So we're going to invert the bottom fraction, flip it around, and now we are multiplying it. Okay, so this got flipped, and once it got flipped, the 2's cancel each other. So we just have this thing left, and that is the reduction formula for the tangent squared, and it's derived from the other two. Okay, so here's a summary of the reduction formula, and take a look at that at the bottom of the page, and then we're going to use it to do some examples. So let's move on to the next page. And what's this? Oh, we're going to and let's look at example 5 on the next page. Okay, and which is on page 853. Let me write it down. Okay, now next let's look at example 5. Now we have given with cosine 4th power of x, but we don't like the 4th power. We need to make this turn into something that doesn't have any power at all. Okay, that is so that is the goal, and we're going to do it with the help of all the reduction formulas that we just learned about for sine, cosine, and tangent. So with those formulas in mind, let's first find the formulas right here. Okay, here's the reduction formulas, and we are going to use this to help us. First, we'll use the cosine squared theta. So this is the cosine 4th is the same as cosine squared. Let's see, cosine squared x, and then squared. which cosine squared theta or x is given by this formula. So we're going to write that down. That equals to 1 plus cosine 2 theta, x. We're dealing with x here, so we'll just replace theta with x. 2x, cosine 2x. Let's see, divided by 2. Okay, this is the formula for cosine squared x that I'm copying from. And so and then there's a squared here. So cosine squared x is being replaced by here. And notice that by doing this, we have reduced the power to 2. But it's still 2, okay? We need it to go down to 1. But we'll do that one step at a time. And for now, then we're going to multiply this thing out. So this one half here, we'll write it up front. This becomes 1/4. And then in here, the multiplication will follow this formula, which 1 plus a squared is 1 plus 2a plus a squared. Okay, that is true. You can verify that by just multiplying this thing out. And following that formula, this will be equal to 1, and where a is cosine 2x, 1 plus 2 times cosine of 2x, and then plus cosine squared 2x. Yeah, remember the squared means the whole thing is being squared. Okay, that's a tradition. And now that we got here, so this is these two things are in the right order. There should be another one, parentheses. And these two things are okay, but this thing still have a squared, so we need to work on that thing. And cosine squared 2x, so we'll only work on that right now. Okay, so cosine squared 2x, cosine squared of 2x, to reduce this, following the same formula, equals to, now this time we'll let theta be 2x. So remember, theta is 2x right now. I'll write it down right here. Theta equals to 2x. Then we'll follow this formula, which means that cosine squared 2x will be 1 plus cosine of 2 times theta. Okay, theta is 2x, so 2 times 2x, and then divided by 2. So that would be equal to 1 plus cosine of 4x divided by 2. Now that we have worked out the cosine of 2x, which equals to this thing right here, then we can put that in here to be the to get the results. 1 plus cos 4x. This line goes all the way across. Yep. Okay. So then, so now we just have to put this in and then do some of the additions. What we have is, I think the rest I will just refer to the book, okay, for you to get through the rest of the algebra. Let's see, where is it? This is example 5. All right. So as you can see in the book, then it plugged in the 1 plus cosine 2 times 2x right in here, which is the cosine squared 2x. It got plugged in. Okay, this got put in, and then we just have to work out the algebra. And so once this, so this is 1/4. Okay, plus 1. This is a quarter times 2 becomes 1/2, and then this thing is. It still have the 1/4 times cosine squared, right, which is this thing, and then this will become quarter times 2 is 1/8 plus 1/8 cosine 4x, and then we have 1/4 plus 1/8, that becomes 3/8, and this stays the same, and then this becomes a 1/8 cosine 4x. So this not that clean of an answer is the right answer. Okay, and most of the time I prefer the answers to be nice and neat, short, and sometimes you get a big long chain of junk. That's just the way it is, and cannot be avoided. So that is that. So next, so please do that yourself as well, and so then we'll move on to example 6, the next problem. I will finish this video. I finish this section in the next video.